Hello and welcome to this 19th Algorithm Selection and Development lecture in this course, Mastering Artificial Intelligence. So in this section, we've been helping you learn how to research, select and develop appropriate algorithms. And as a part of that, we will now talk about how to use the feature importance analysis to provide insights into the model prediction. Because you not only need to develop a model and make the prediction, but also provide insights into the predictions. So we have looked at in the last three lectures the first step of how to use feature importance analysis of training the model, and now we are ready to look at the remaining steps. So we'll start looking at. So how do you think you can calculate feature importance scores to use feature importance analysis and provide insights into model predictions? Any thoughts? See, what you need to do is first you need to, after training the model, calculate the feature importance scores. Different algorithms have different ways of calculating the feature importance. For example, decision tree, the feature importance can be inferred from how much each feature decreases the impurity in the tree nodes. Now, what this impurity in the tree nodes is, we will talk about that. The random forest algorithm, you need the feature importance can be computed by averaging the decrease in impurity over all the trees in the forest. So it builds on the decision tree model. Obviously, because the forest is consisting of many trees, so you need to average it. Then the GBM algorithm feature importance can be calculated by the total decrease in loss, which is you can say mean squared error attributed to each feature across all the trees. And in the linear model, the coefficient of the feature can be directly indicated by we can directly indicate their importance. So the importance is represented there by the coefficient of the features that are in the linear model. So that's how you can calculate the feature importance score. So the question is, what is impurity in tree nodes? So let's look at what is impurity in tree nodes. So in the context of decision trees, impurity refers to the degree of uncertainty or disorder in a node. Decision trees are constructed by repeatedly partitioning the data based on the features with the goal to reduce impurity or the uncertainty at each step and making your predictions more predictable. There are different impurity measures used in decision tree algorithms such as Gini impurity and entropy. Let's take a look at each of these. So what is Gini impurity? Now Gini impurity measures the probability of correctly classifying a randomly chosen element in the data set if it were randomly labeled according to the distribution of the label in the node. Now this typically ranges from 0 to 0.5, where 0 indicates the node is pure, all samples belong to the same class, and 0.5 indicate maximum impurity, samples are evenly distributed among the classes. The second method is looking at entropy. Now, what is entropy? Entropy measures the average amount of information needed to classify a sample in the data set. Now, it is calculated as the sum of probabilities of each class level multiplied by the logarithm of that probability. Similar to Gini impurity, entropy also ranges from 0 to 1, where 0 indicates a pure node and 1 indicates maximum priority. When constructing a decision tree, algorithm chooses the feature and split point that minimizes impurity in the resulting child node. Now, this process is repeatedly done until the certain stopping criteria is met, such as reaching a maximum number of trees. Now, having looked at two things, how to train the model and then calculate features importance score, we will now look at how to visualize the feature importance. So, how do you think you can visualize the feature importance? See, once you have obtained the feature importance scores, which you need to visualize them to gain insights. Now, common techniques include bar charts, where you plot feature importance score as bars to easily compare the importance of different features. Also, heat maps, where you visualize the importance of features in a heat map that can help identify patterns and correlation among features. And also, you can use scatter plots that can be used to visualize relationship between feature importance and other metrics such as feature values or target variable values. Uh, the next step is to interpret insights after having visualized them. So how do you do that? Any thoughts? So the analysis of visualization is done to interpret the insight gains from the feature importance analysis. And to analyze, you need to ask few questions as always. So what are the questions that you need to ask? Let's take a look at that. The first question that you need to ask is, what feature has the highest importance scores, right? What features have the highest importance scores, which are at the top of the feature list? Now, these are the most influential features in making prediction. The second thing that you can ask is, are there any surprising or unexpected elements, results? For example, are there features with low importance scores that were expected to be important? Then the last thing you can ask is, are there any correlations or interactions between features that influence their importance? So like this, you can interpret the insights by asking these questions. So having interpreted insights, the next thing is to validate the insights. And how can you validate the insights? Let's take a look at that in the next slide. So, validating the insights gained from feature importance analysis is done by examining how well they align with the domain knowledge or by conducting further experiments or analysis. Now, this could involve the experiments analysis could involve testing the impact of removing certain features on model performance or conducting sensitivity analysis. And that's how you can validate the insights gained by interpreting the feature importance. The last thing is to iterate and refine. And how can you iterate and refine the feature importance analysis that you have done? Let's take a look at it again. So, use of iterative insights gained from feature importance analysis to iteratively can improve your model. So, iterate and refine can continuously improve your model. Now, these are the things that you can do to iteratively improve your model. First is feature engineering. Second is selecting subsets of feature and refining modeling approach based on importance of different features. Now, we will take a look at some of these as we go forward in further sections, and especially the feature engineering that can cover the first two part of that. So, by following these steps, you can leverage feature importance analysis and gain valuable insights into your machine learning model's predictions and improves its performance and interpretability. So what is next? So having looked at how to use feature importance analysis for interpretability and explainability, we will now look at, there are some models for interpretability methods. There are some model interpretability methods that we will take a look at, like SHAP values in line, that can help you consider the interpretability and explainability of the selected model. So thank you so much for selecting this 19th algorithm selection and development lecture. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question. And also download the PDF file to take a look at anything that you want to.